Yes, good morning to all. This is Anvesh from Triple A branch. So I just want to explain uh, the membership operator and Bitwise operator today. So, what is a membership operators? Membership operators are used to test if a sequence is present in an object or not. If you take any sequence like list, tuples, or else sets, dictionary, strings, whatever it may be, uh, if we want to, if a particular element is there in that sequence or not, is to find the membership operators. So, if I show the example to you, there are two types of membership operators, like in and not in operators. Well, coming to in operator, it returns a true value sequence with a specific value it present in the object. What it mean, if the element is present in that list or else tuple, whatever may be the sequence you are taking, it prints true. Like if you see the example, this I took a list called X, apple and banana, and I print banana in X. So we are using here is in operator. So it prints true because the banana is there in that list. So it prints true. The next is not in operator. It is a reverse of in operator. So what is this? If you say X is equals to apple and banana, print pineapple not in X. Yes, it is true, but it returns false because it is not an operator. I mean, the before I said it is a reverse of in operator. So if if the va- if the answer is true, it prints false, or else if the answer is false, it prints true. So next, bitwise uh, bitwise operators. uh, these bitwise operators are like same as logical operators, but in logical operators we are performing with uh, like less than, greater than, or equal to, whatever maybe, with between two identities. But here also will do same thing with their binary form, like uh, giving a variable, and we need to do in binary form, like zeros and ones. If I show the example, there are total six types of bitwise operator. Coming to first one, the types of bitwise operators, like first one is an operator. Okay, it is the same rules of it is the same as logical operators, like this. If the both operands are true, it prints true. If the first one is, if both operands are true, it prints true. Next one, if both operators are false, it prints false. if one of the if either one of the if either one of the operand is false, it prints false. So we'll see an example. Here I took a variable a. The value is 10. If you see the binary form of 10, 1010. And if you see the b, I took a 4 value, 0100. To find bitwise and operator, we use and symbol. It means, if you do this it prints zeros, because if you what I said, if both operands are 0, it prints zeros. If both operands are 1, it prints 1. If either one of the operand is 0, it prints 0. So if you see this example, both mm, uh, if you see this example, uh, 10 and 4, it prints 0, because the conditions what I said is the conditions what I said you can apply here. Next one is bitwise or operator. Bitwise or operator, it is uh, it it says that if either one of the operand is true, it prints true. Okay, if you see the example there, same 10 and 4. If you see 0 and 0, it prints 0. 1 and 0, it prints 1. 1 and 0 and 1, it prints 1. 1 and 0, it prints 1. So 1 1 triple one zero. So triple one zero, the binary form is 14. I mean the variable is 14. So this is how the bitwise OR operator done. Next, coming to bitwise not operator. The bitwise not operator returns one complete of the number. It means you need to add a plus one to the binary form, uh, and you need to keep a minus sign uh, before that. It means a minus. If you see the binary form of 10 1 0 1 0, and we need to add a number, and we need to add a plus 1. So if you see the 1 0 1 1, so the binary, I mean the decimal of this binary form is minus 11. If there is a trick here, if you know, if you take 11, the binary form, I mean the bitwise not operator will be the minus 11. If you take 22, the bitwise not operator will be minus 23. It means we are adding a number before that. I mean we need to keep a negative sign. Okay, you need to remember this if any. And coming to bitwise XOR operator, it prints if both operands are 1, it prints zeros. Okay, if you see here, the both operands are zeros, so 0. If here see, if either one of the operand is 1, it prints 1. And if either one of the operand is 1, it prints 1. If either one of the operand is 1, it prints 1. So if you see this same, if I take, if you see, if we give 1 1, so it can be do this. I mean if both operands are 1, it prints zeros. You need to remember this. So okay, now coming to bitwise operators, I mean sorry, left shift and right shift. You need to simply remember that if, I mean whatever we are shifting, if we give a number like 10, and we need to shift to right side. It means same example, to 10 shifts are 2 to right side, means we need to delete two numbers from last. For left shift, we need to add two zeros. How many shifts are you taking, you need to add those many zeros to the last. Okay, if you see here the example of right shift, what I said to right shift, we need to delete two numbers, and we get the respected value here. Okay, now coming to bitwise left shift and bitwise left shifts. Okay, yeah, what I said, bitwise left shift, we need to delete, I mean we need to add two zeros before that one. So it is the thing we need to do. Okay, so thank you. So uh, these are the various types of operators. I mean if you see more, there are more type of operators like bitwise, whatever I said, bitwise membership, logical, arithmetic operators, and so many are there. But uh, I said two. So thank you. I think you have understood my concept. So thank you all.